once again with a geography exam coaching lecture. So in this case we are revising questions related to rivers and weathering. So please take note. For more information, for questions and inquiries, contact the number on the screen. June 2014, that is geography paper 2. So in this case the question says describe the describe the processes of physical weathering. So on item 1 the question says in areas experiencing hot dry climate. So when we are talking about hot dry climate, we can take note of what we call semi-arid and arid region. So when we are talking about semi-arid and arid regions, we are talking about regions whereby there will be high temperatures and low rainfall. So for instance, we could have savanna climate or desert. So physical weathering processes that are dominant in this hot climate, we can take note of exfoliation, we can take note of dilatation, but in this case we are going to explain what we call exfoliation. So exfoliation, it is a physical weathering process that is dominant in semi-arid and arid regions where temperatures are always high throughout the year. So what happens is during the day, the granite rocks, they absorb heat due to the influence of micas, and during the night they emit heat. So as a result, by the time the granite rock absorb heat, they expand and increase their tensional stresses. And during the night, when these rocks emit heat, they contract. So this expansion and contraction process will cause the rock to disintegrate in an onion-like structure where rock fragments they fell off from the permanent rock and collected the talus. That's how I'm going to explain about physical weathering process. Then item 2, the question was requiring on exposed mountain summits experiencing temperature fluctuations around 0 degrees Celsius. So when we are talking about the temperature around 0 degrees Celsius here, we could have influences of frost shattering. So in this case, what happens is when we are talking about frost shattering, what happens is frost shattering, it is a physical weathering process that is dominant in areas where temperatures can be below 0 degrees, or when temperature can be maybe at 0 degrees or to minus 10 degrees or either minus 2 or whatsoever. So frost shattering, it is a physical weathering process which occurs when water percolates or water collects through rock joints. As water percolated through rock joints in a liquid form, as temperature falls from 0 degrees, this water will turn into ice. As this water turns into ice, it will cause the rock to also to expand. But as temperature increases from 0 maybe up to 10 degrees or whatsoever, the water will turn into liquid. But as the water turns into liquid, the rock now will contract. So frost shattering, it causes the rock to contract and to expand, leading to block disintegration. And as a result, there will be the formation of landforms or the formation, so the accumulation of rocks at the talus. Then B, the question says, Fig 1 shows part of the river course. Now we have been provided with the river course, as we can see. So the question says, name the features marked X, Y, and describe how they are formed. So in this case, what are we going to do? In this case, we are going to do like this. So B, item 1, we are going to say, in this case, landform. Here. Then here we could have description like this one. So our landform X, it's an oxbow lake. Then we are going to describe here that it is a river depositional feature which is formed at the lower course of the river. So it is formed when the meandering of the river is so acute, and at the same time lateral erosion will be dominant on the outer banks, depositing sediment on the inner banks. And with the time there will be a cut-off, and that cut-off will lead to the formation of an oxbow lake. So I just want to see. So when we are talking about an oxbow lake, it is formed in this way, like this one. So this is the direction of flow. So the water will be flowing in this direction. So if the water will be flowing in this direction, here we will have lateral erosion. So as lateral erosion takes place here, water cannot circulate here with the sediment. So it will deposit sediment here. As the water will be circulating here, it cannot also move with the sediment at this place. It will deposit sediment. So with the time there will be a cut-off whereby this cross-section in which I've indicated PQ, there will be a cut-off which results in the formation of an oxbow lake like this one. As the water will be having a new channel, then here we would have a sediment. That's how an oxbow lake is formed. Then why, when I'm talking about why here, why it's a braided channel. Why it's a braided channel. So we are going to explain in our description. We are going to say a braided channel, it is formed when deposition takes place at the middle course, whereby the river has lost its velocity. So as a result, the water will flow circulating its sediment downstream. That's how a braided channel is formed. For instance, we could have this could be our channel. For instance, this could be our channel. In this case, we could have a channel like this one. So as good having a river channel, this will be said deposit, another said deposit. This is direction of flow. So water will be flowing, circulating its deposited sediment. For example, this could be another sediment, this is sediment, this is sediment. So water will be flowing in between, circulating these sediments. They will be appearing like islands in the river. That's what we call braided channels. So when they say in this case now, they are requiring you to draw a cross-section along line PQ. This is the cross-section that I've already indicated. You could draw a river channel with an acute angle whereby we could have sediment here, and the lateral erosion, you indicate direction of flow. Then you put a cross-section like this. This is what they want you to show. Then after that, they say on the party C, they say suggest measures which may be taken to reduce problems of siltation. So item 1, we are required to outline how can we reduce problem of siltation. We have what we call river dredging. River dredging is a process whereby individuals, they can go on the river channel, they remove sand. Also, we could have avoid stream bank cultivation. We can avoid stream bank cultivation here. Also, construct artificial levees. They help to reduce sand deposition in the river. Then item 2, the question says, how can we reduce pollution in rivers? We can have awareness. We can have educational campaign. Also, another method we can use to reduce pollution in rivers, avoid dumping boiler waste. But some they call it thermal waste. Thermal waste is whereby industries, they can dump water in the rivers. Also, avoid injecting industrial effluent in rivers. So this is what, these are the measures I mean. So for more information, if you find this video interesting, you can subscribe, you can like, and you can share. You can contact the number on the screen. Thank you very much.